All right, today we're going to pull back the curtain on some of the data science that literally powers the modern world of shopping. We're going to get into two really cool ideas: frequent item set mining and association rules.
You've probably had this happen, right? You're shopping online, and the recommendations it's giving you are, well, they're a little too good. Or maybe you've noticed some weird product placements in a store, like putting beer right next to the diapers. I promise you, that's not random. It is some seriously powerful data mining at work.
So let's start with the legend that basically kicked off this whole field of analysis. The story goes that a supermarket discovered this really strange pattern. Customers who bought diapers were also, surprisingly often, buying beer on the same trip. Now, this wasn't just a funny coincidence. It was a data-driven insight that led stores to literally move beer and diapers closer together. And boom, sales for both went up.
So, the technique that uncovers these hidden little connections is called association rule discovery. And the goal is actually pretty simple. It's all about digging through these massive mountains of sales data to find interesting and profitable relationships between different items. And today, we're going to break down exactly how they do it. Okay, so if we want to find these rules, where do we even start? Well, the very first thing we have to do is just figure out what's popular. I mean, we can't build a rule on a combination of items that only one person has ever bought. We need a way to measure that popularity, and for that, we use a simple concept called support. To see how this all works, let's just use a super simple little data set. Imagine these are 5 shopping trips from a store. Each row is one transaction, and it has a transaction ID or TID. So you can see in that first trip, TID number 1, the customer bought bread, Coke, and milk. Simple enough, right? And the concept of support? It's incredibly simple. It's not a percentage. It's not some crazy formula. It is just a count. The support for an item or even a group of items is just the total number of baskets it shows up in. That's it. No fancy math yet. So let's do a quick check. Looking at our little table here, what do you think the support is for the item set beer, bread? Or to put it another way, in how many of those 5 baskets do you see both beer and bread? If you said 2, you got it. Perfect. Let's just double check. Basket number 2 has beer and bread, and so does basket 4. Baskets 1, 3, and 5? Nope, they're missing at least one of those things. So the support for the item set beer, bread is exactly 2. Now, in a real store with millions of items, you can't possibly track every single combination. You'd go crazy. We only care about the popular ones, and that's why we set what's called a minimum support threshold. Think of it like a bouncer at a club for data. An item set has to be popular enough to get in. So if we set our threshold to 2, our beer bread item set makes the cut, and we can officially call it a frequent item set. All right, so now we have a way to find the popular groups of items, our frequent item sets. The next step, and this is where it gets really cool, is to turn them into these predictive if-then rules. And this brings us to our second key idea: confidence. An association rule is really just a formal way of saying, if this, then that. The if part is technically called the antecedent, and the then part is the consequent. Our entire goal here is to find rules where, if you see the if items in a cart, it's super likely that you'll also see the then item. But, how do you measure super likely? That is what confidence is for. Confidence basically gives our rule a score for how reliable it is. It answers a very specific question. Of all the times a customer bought the stuff in the if part, what percentage of the time did they also buy the stuff in the then part? Now, the formula for calculating this might look a little intimidating, but I promise you, it's actually really intuitive. All you do is take the support of the entire item set, that's the if and then parts all together, and you divide it by the support of just the if part. Let's just walk through an example. It'll make perfect sense.
Okay, let's figure out the confidence for the rule: if someone buys milk and diapers, then they will probably buy beer. First, we need the bottom part of that fraction, the support of just the if part, which is milk, diaper. Looking at our data, that combo appears in baskets 3, 4, and 5. So its support is 3. Now for the top part, the support of all 3 items together: milk, diaper, beer. That happens in baskets 3 and 4. So its support is 2. And now we just plug in the numbers. Confidence is the support of all 3 items, which was 2, divided by the support of the if items, which was 3. That gives us about 66.7%. So what does that mean?
It means in our tiny little dataset, this rule is right about 2/3 of the time. Pretty reliable.
Now, all of this seems pretty straightforward with just 5 baskets, doesn't it? But what happens when you're dealing with a real store? We're talking millions of items and terabytes of data. Just trying to check every possible combination of items would literally break any computer on the planet. And that's where we need a really, really clever algorithm.
I mean, let's just try to grasp the scale of this problem. If a big store has 1 million unique items for sale, the number of possible pairs of items is about 500 billion. Trying to keep a simple counter in memory for every single one of those pairs would require terabytes and terabytes of RAM. It is just computationally impossible. We have to have a shortcut. And that amazing shortcut is the a priori algorithm. It solves this memory problem with this brilliant 2-pass approach. On the first pass, it doesn't even look at pairs. It just reads through all the data to find the individual items that are popular enough to meet our support threshold. This gives us a much, much smaller list. Then, on the second pass, it only bothers to count pairs that can be made from that short list of frequent items it already found. Now, the logic that makes this so mind-blowingly efficient is called the a priori principle. It's so simple, but it's genius. It basically says that for a pair like diapers, beer, to be frequent, then both diapers by itself and beer by itself must also be frequent. I mean, think about it. A group of items can never appear more often than its individual parts. If only 50 people in the whole store bought some rare spice, then the pair of rare spice, steak, couldn't possibly have been bought more than 50 times. This a priori, or from before, knowledge lets us just ignore a massive, massive number of pairs without ever even needing to count them. So, we've been talking a lot about supermarkets and groceries, but the real power of this whole model, this idea of finding frequent items in baskets, is how incredibly flexible it is. Just think about how versatile this is. The items could be words, and the baskets could be documents, which helps us find what topics are being discussed in millions of articles. The items could be base pairs, and the baskets could be genes, helping scientists find genetic patterns. It's even used with drugs and patients to discover potentially dangerous drug interactions. And yep, this is the exact same logic that powers Amazon's "people who bought this also bought that" recommendations. So you can see, this technique goes way beyond just selling more beer. Finding these frequent patterns and these strong associations is a fundamental building block of modern data science. And as we apply it to these unbelievably massive data sets about our health, our planet, our society, it really makes you wonder, what are the next diapers and beer discoveries hiding in plain sight, just waiting for us to find them?